to the thing. Just need to go right to the end because I told you about the phone. All we need to do is to come here. All right. We say, okay, except alcohol and carboxylic acid. You see, these ones, they've got the strong intermolecular forces. Let's just tell them what it is. That's where you've got the hydrogen. You got hydrogen. It's a hydrogen force. So the force is stronger. It's greater, going up. Then the energy to break the bond, it must be greater as well. You good, right?
Yeah.
Yeah. And then the energy for molecules is still energy. It goes up. Then we're talking about boiling and melting point. They are also up. When you talk to vapor pressure, it's the opposite. That's the only stranger. You see, it goes quick. It goes the same with the other one. Alkane, alkene, alkyne, and all of that. They've got weak intermolecular forces, meaning the force is very low. It's very less. So will the energy to break or to move the molecule, the energy is less, boiling point, melting point, it's less. The only stranger is vapor pressure. It will go the opposite. It goes greater. Is it making sense?
Yes, sir.
Okay, now, let's say now they pick alkanes, 2 alkanes. Maybe they give you CH4. And then they give you C4 and then H10. In other words, both of them belongs here. And then they say, how come? Well, all of them, they've got weak. They say, but this one here, the butane, in comparison with this one, the alkane with alkane, this one has a greater boiling point. Why is that? Because of the number of carbon. Can you see? It's more massive. There's a whole lot of carbon. Can you see that? Yeah. When they compare it with the same of its kind, then you say, no, this one has got more. All right. Yeah.
Sir?
Yes, sir.
Sir?
Yes, sir.
Are alcohols more likely to evaporate?
Yes.
Like without okay.
Yeah, they are more likely to evaporate. Absolutely. So that was a shortcut of that. But then if we wanted to talk about it, sometimes we can say other one has got longer chain, short chain, because this one is short chain. That one is longer chain. Yeah. It's basically that. Okay, so you see, we're done with that. Let me just say some of the other points here. One of the points here, because it was the intermolecular forces, so we explained that part. We're done. Then the other one is the functional group. When they're talking about functional group, is that same thing of the intermolecular forces, because with an alcohol OH, you're gonna have what is that hydrogen bond. We took care of that one. All right, then we come here. If the chain is longer, the one I just give an example, 1 carbon, 4 carbon, long chain. So it's too much. It needs more energy, stronger. The other one, it's a molecular mass. Okay? More carbons, more molecules. We summarize it there in the end. I'm just taking the thing. And then the other one has branches. Now, the one with branches, you see, they say the smaller surface area. And then the van der Waals forces. Remember, when you've got smaller surface area, it's actually a whole lot tougher to break it. Let's say you've got a long stick like that. It's easy to break it, but if it's so small, so minute, it's stronger, isn't it? Yeah. Like a matchstick. You break it into 2 pieces. Take the other half, break it, fine. The other quarter, try to break it. It's a little bit tough. Why? Because it's short. The mass are concentrated at the center. They're packed together. Here's an example. Take a piece of paper, an A4 paper, a paper. Throw it to somebody else. It does not hurt. But take the very same paper, all right, and then squash it together. Make it like a little ball. Throw it at somebody. It hurts, isn't it?
Yeah.
Yeah. It's like you're kneading it like a dough. You know?
Yeah.
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 Yeah. Because the mass is the mass is not scattered all over. It's like taking jelly tots, put them together. They combine to make a big ball like a tennis ball. They hurt. But when it's individual, it's not that bad. So I'm just giving you those ideas. And